Good afternoon and welcome back to my electronics workbench, where today I'm going to be doing things a little bit differently. In addition to using a different camera, which is a Panasonic Lumix ZS35, which I just want to try out to see how it goes, I'm also going to be doing a tutorial of sorts instead of doing any repairs or anything like that. So basically it's to do with making printed circuit boards, and the idea is how do you go from a circuit board layout, for example this one here, which isn't going to be the one I'm actually going to work on, but it's just the first one that came up. So how do you go from a printed image in a book or a magazine or one you've downloaded off the internet that someone scanned, for example, how do you go from that to an actual board, physical board here? And this is not the board I'm going to be making, obviously, because this one's already made, and this isn't the board I'm going to be scanning. But I'll show you the real one. Hang on. This is the one I'm going to be scanning, and I haven't made the board yet, which is why this video is going to be part of making it. But this is just going to be the first part, basically. The tutorial on how to scan the image, how to process the image, how to convert the image, and get it ready for printing, so you can apply it to whichever PCB manufacturing process you're using, be it toner transfer or UV resist method or whatever you're doing, basically. So just a short video on that. I won't go into any more detail past that about how to actually etch the board or anything like that. I'll probably make some separate videos for the different stages to do those things, but this one basically is just to get the image off the page into the computer and have it all ready for printing. So there we go. Now I'm using Linux, and I'm just using the basic scanning program which comes with Ubuntu, which is the version I use. Obviously, whatever you're using, Mac, Windows, Linux, whatever, you'll probably have some scanning program that comes with your scanner or whatever, or even if you go down to the library or something and scan it on a public photocopier. Anyway, whatever, you want to get an image. But basically, I'm just going to go over some of the settings for that. So just say check out the resolution. Make sure you're doing at least 300 dpi. 150 is probably usable, but I would recommend at least 300. Probably you don't really need to go higher than that for most cases. If there's a lot of fine artwork in the PCB layout, maybe go for 600, but above 600 is pointless, I think. If you find like a scanned image on the internet somewhere that someone else has scanned for you, it might be a lower resolution, but hopefully at least 150. Should do that. And you want to scan in color, by the way. It's tempting, I guess, to scan in grayscale or black and white, because that will result in a lower file size, or it might be faster, or you might think that makes sense because we want a black and white image at the end of this process. But the truth is that a lot of scanning programs and scanners often try to do clever things. If you scan in black and white, they try to like adjust the image itself automatically and do silly stuff. So it's better just to scan default color. Don't use magazine settings or any sort of image enhancement options, because typically they pre-edit the image as they're scanning, and the results aren't always as good as what you could get if you just edit the image yourself afterwards. So I've got here the quality set to maximum. I've got the resolution on 300 dpi, and I'm going to scan this basically in color, just a basic scan. So obviously, your scanning application will probably look different, unless you're using the same one here, but whatever, they're all pretty much the same, and it doesn't matter which way up you scan either. I mean, I'm scanning this upside down, but it doesn't matter, we're going to edit this anyway, so you can flip it around afterwards. It's irrelevant. In terms of getting the picture straight when you scan it, straighter the better, I think, but again, even that's not really necessary. Anyway, so then the next step obviously is to save it as an image file. I'm using PNG because that's the only lossless option that the scanning program has. But any lossless one, bitmap, PNG, whatever, I mean that's probably the best thing to do. Because again, the processing we need to do to this, it's a better idea than if we use JPEG. Saying that, a high quality JPEG will work fine, but I prefer to go for a lossless image format when I'm doing this kind of work. So I've saved this as a PNG, and now I'm going to open it in a program called the GIMP image editor. This is basically a free sort of open source alternative to Photoshop. It's a cross-platform tool you can get for Windows, Mac, Linux. It's pretty good, especially for the fact that you pay nothing for it. I'll put a download link in the description if you wish to download this yourself. Anyway, so opening this up, and then we can open the image we just scanned, and there we go. So obviously the first thing with it is to rotate it so that it's up the right way. So we just go to image menu, transform, rotate 180 degrees. So now it's up the right way. Don't flip it horizontally or vertically. That will obviously create a mirrored image. Whether or not you need the image mirrored will depend on what PCB etching process you use, what way you do the etch resist. So whether you're doing a UV method or a toner transfer method. So now I'm just going to crop the image basically down to a rough sort of size to include the whole image. Obviously I can't go in too close because it's not perfectly straight, so I'm going to leave a little gap between the edges and just press enter in GIMP to crop after you've selected what you want to crop to. The next part I'm going to do is turn on the grid. Now this is to help me align the tracks and everything, and I can see if everything's been rotated to the correct angle to get it nice and square. But before I'll do that, I'll actually desaturate it to black and white, or grayscale I think. There's 3 different options you can choose for this. I just go with the default lightness. You might get better results with one of these 3 different options depending on your scanner and what the quality of the page was you scanned. For this particular one there doesn't seem to be any difference, and I should have turned the grid off I suppose while I did this, but hey, doesn't really matter. So I'm just going to choose lightness, and there we go, it's desaturated. Anyway, so now I want to rotate it. So we just zoom in here to get the grid lines next to the tracks and just change the angle slightly until the PCB traces line up pretty well with the grid lines, and then do the rotate, and basically yeah, everything should pretty much match up. You can check the corners, check the center, as long as everything's roughly matching up, then you shouldn't have a problem. And then I'm just going to crop it again to get it down to the basically the overall correct size for the board size that I require. Just check all the corners, make sure nothing's getting cut off, and then crop again. So the next part is to change the levels. And obviously this is much easier to do it when the image is now being desaturated. If we tried to do this while it was in color, it would be a lot harder, so that's why you want to reduce it to grayscale first before you do this. And then you can just basically play around with these options. Again, this will depend on the image you've scanned and the quality and your scanner and all that, but basically you can just change these levels around. You want to get whatever's the best contrast between keeping the track artwork as dark as possible and keeping the background as light as possible, but without the effect sort of cutting into the fine detail areas of the picture. So look at the finest detail, for example this text here in the image, and we can see that the text is still perfectly readable, it's still the correct shape, and we do have a really good contrast between the black and the white, so that's basically what the sort of result we're looking for, a really clean high contrast image. And then we can export that to another PNG after I've edited that. That's basically all we need to do in GIMP. Again, making a note, obviously keep it PNG, keep it some lossless format. PNG is pretty good. So the next part of this is using another program that's called Inkscape, and again it's a free cross-platform open source program you can get, and I'll put a link for that one down there as well. Inkscape is a vector-based editing software, and it's kind of comparable, I guess, to Adobe Illustrator, but again it's free. So we open the PNG that we edited in GIMP into this. The default import options should be fine, but just make sure you select the resolution from the image. Otherwise you could get a size issue and a scaling problem with the image, and then your PCB will come out too big or too small, and that's never fun. So basically we only really need to do one thing in this, and that's to use this tool called Trace Bitmap, and basically what this will do is it'll trace around all the edges in the image and convert it to a vector, or it'll make a vector copy of the bitmap in the same document. And again, the default options in this tool should work perfectly fine. Although I did manage to confuse myself here, and I forgot to actually select the bitmap before I attempted to apply the tool. So just make sure you've actually got the image selected. When you press update or choose live preview, it should show up in that little window, and that'll show you if anything's working. So select that, press OK, and now we've got the vectorized copy of this basically just pasted directly over the top of the bitmap. So we can close the tool, and I can move that off from the bitmap version. So now we see we have two versions. I can delete the bitmap, and we've got the vector version now. And if we zoom in on the image, you can check the detail. You will notice that it's not perfect. It's not exactly the same as the original scan copy. And you'll notice that some of the corners, some of the shapes do look sort of a little odd, but that's just the way Inkscape does it. You can't really get around that. I think Adobe Illustrator may do a slightly better job at this function, from what I remember. I did use it once for this, but I mean, the results are perfectly acceptable anyway, and I kind of like the artistic kind of style it creates. It's sort of reminiscent of the old hand-drawn boards from the 70s and 80s, and yet it still has the geometric precision of like a taped-out board or a CAD board at the same time. So it's kind of interesting mixture of the kind of styles. I quite like it. But anyway, I mean, basically it doesn't really matter if the pads aren't exactly round or exactly square. Basically the main reason why we're doing this is to get the edges all nice and clean, because if you were to photocopy the original artwork directly, or even to print the bitmap image that I'd edited in GIMP just directly, the edges would still be quite sort of feathered and not really clearly defined, and so when you come to actually etch the board and create the resist pattern with that kind of image, the edges don't etch very well. You get quite sort of rough edges, and you can get, you know, etchant going in under the resist, and you can get kind of, it just comes out quite sort of horrible. So even though the results aren't perfect, you definitely want to convert it to some kind of vector image, because the alternative just doesn't really work very well for actually etching the board. It's also worth noting, when you do the bitmap tracing, there's also an option to invert the colors on import, and this will obviously depend on whether or not you're doing a negative etch resist pattern or a positive etch resist pattern. Usually I think you'll want a positive image if you're doing toner transfer, and usually a negative image if you're using UV sensitive film, because that's usually negative acting, although sometimes you can get positive acting stuff as well. But I mean, again, yeah, it just depends on what process you're using. It is easier definitely to invert first when you import, and if you don't know, then just make two copies. And another good thing to check is to make sure the size actually makes sense. So I've selected the image here, and I've gone up on the toolbar, and I've selected millimeters for the dimensions, and now it's showing me that the width is 149.2, height is 114.9, and we can see 149, 114, that's pretty much exact on the dimensions that the magazine article, they're not exact, but you know, a millimeter or or so out is not really a big deal, especially for a board like this. Quite a basic layout, a lot of big clearances everywhere. You know, it's not gonna there's no surface mount parts. It's not going to be an issue if the thing is slightly stretched, and if it was, you know, you can always edit that afterwards. You can print it, make sure it comes out, because of course printers have different scaling as well, so when you print it, it may not come out exactly the same size as you expect. So if you are doing something with quite fine pitch components, surface mount stuff and things like that, it is worth definitely doing like a final test print on paper, and then actually comparing all the details. Check the pin spacing, pad spacing, pad pitch and that kind of thing on any critical components, and just make sure that they all make sense. And if they don't, then, you know, adjust the scaling of the image to suit your printer or anything like that before you actually print to your toner transfer paper or your transparency or whatever you're using. So I'm just checking that, and yeah, I mean, exactly, it matches up pretty much fine. I mean, the height is slightly bigger, but yeah, it's good enough. So now we basically just save this image as a vector file, and you can choose SVG, or you can export to PDF or PostScript or whatever, you know, if you need to use one of those. But you basically can print direct from Inkscape later on, so that's kind of all you really need to do. Unless you wish to send this to a board house, in which case you'd probably want to export it to PostScript and then do some sort of conversion to Gerber, and then you'd want to send it to a board house. Obviously you won't get any solder mask with this kind of thing unless you do that yourself, which would require manual creation of a solder mask thing, but this layout's designed for a basic single-sided board with no solder mask or anything, so yeah, I mean, all you'd have to really do is just convert this to the appropriate Gerber layer file and just send it into board house, and they should make it. But, you know, given the size, for example, of this one, it would be quite expensive, and that's why I do boards like this, single-sided. It's easy at home and much cheaper. I mean, you can buy really cheap blank PCB material on eBay and that. So there we go. Hopefully that video was informative. Hopefully it was clear and obvious how to perform the steps which I have shown here, and hopefully it's useful to someone. Like I said, I'll try to make more of these to do the whole process from image to board. So I'll do everything, including, you know, printing to toner transfer paper. I'll also do another one for the ultraviolet etch resist photo method. Go through the cutting the board, etching the board, tinning it, drilling it, and obviously installing the components. So a whole full thing, showing the two different processes which I use depending on what I'm doing. And I guess that's about it for this one. So hope you enjoyed that, and see you next time. Okay, so scene 2. This is the end of the video. Oh, I might as well leave with a little bonus section at the end here as well, which is basically I had to edit this board layout slightly because the scanned copy I made did actually have an error in it, which is a known error for this particular board. So I had to move the location of one pad and change one trace slightly. And yeah, the way I'm editing this is probably a bit cumbersome and a bit sort of silly, but yeah, I'm not that great at image editing, but you know, the results should be more than adequate to provide what I need. So here's basically. So yeah, if you do scan one of these images, and you need to make some edits to it, yeah, you need to kind of do it the hard way. Unfortunately, it's not easy like editing a actual PCB layout that's already in a CAD software. But yeah, just got to do it all by hand. I suppose you could print it and then edit it on paper and then rescan it or something, but it's probably easier to do it digitally, to be honest. So I'm just sort of cutting bits out. Not probably the best way to do it. I probably could just do it with the tool, but the mouse precision is not that great, so I found it easier to just cut other bits out and do it that way. Yeah. So there we go. And we can see the bit I'm editing with this overlay part, and what it's supposed to look like, and what I'm changing it to, and all that. So yeah, not bad. And there's the resulting edited image, which has been fixed. There's basically a short circuit between two pins on the IC that shouldn't be there. They should be there should be a capacitor and a resistor in series instead of a direct short. There we go. So there we go. If you've watched this far, hopefully you've enjoyed everything, and hopefully it's been useful in some way.